Think okay. Hi everyone, my name is Chen and I'm from St. John's Institution 5J class. And today I'll be covering about linear programming, which is the seventh chapter of our Form 5 KSSM syllabus. So what will we learn from this chapter? Firstly, we'll learn about linear programming model and linear programming applications. In these applications, we will learn how to apply all the skills learned in this linear programming model subchapter into daily situations and solve them. So why should we learn this chapter? Is it important? Most of us think learning this chapter is like a waste of time, but there are many importance on why we have to learn this chapter. So linear programming is used widely in ecology, transportation, and event organizers to minimize cost and maximize profit. Computer software experts too use linear programming to solve problems involving thousands of variables and constraints on daily basis. So from here, we can see how widely used is this linear programming chapter in our daily lives and in our future professions. So for the first subchapter 7.1, we'll look into linear programming model. So usually linear programming problems are in the form of problems of money, manpower, raw materials, and businesses. Businesses like bakery and florists and etc. So there is a formula to solve linear programming model questions. So firstly, we should identify the decision variables. Decision variables describe the decisions that need to be made and can be represented as in the format of x and y. Like we take x equals as the length of the rectangle while y equals to the width of the rectangle. So the second step we'll need to identify the objective function. It is a function that needs to be maximized or minimized. So from here we'll find the maximum value and the minimum value. And next, we'll identify the constraints. We must present the existing constraints in the form of equations or linear inequalities. We use symbols like this: equals to, less than equals to, more than or more than or equals to. So the constraints must be in terms of the decision variables. So in the form of x and y. So from here, we can see the objective function stands for a function used to determine the optimal value, while constraint is the limitations like lack of raw materials, capital, and so on. So in order to determine and to apply the appropriate inequality symbol, so we have learned this whole thing in our chapter 6 from 4 maths KSSM syllabus. So here's a flashback. So moving on, we'll look at some examples on where we should shade the shaded region. This is just like a flashback on what we have learned in Form 4 and how we should plot the graph and what line should we use. So the moment we look at these graphs, we can see there's a difference in the line of the straight line of the graph. So you see, this is a solid straight line while this is a dashed line. So we use dash line when the linear inequality is this one without the equal sign. So it's just less than or more than. When we use solid line, we'll need to see if there's the presence of this linear inequality sign or not. So it's like more than or equals to or less than equals to. So when y is less than 4, we'll shade the region below. So when y is, so if we switch the sign y to y, oh, can't see this color. So if we switch the sign from y is more than 4, we'll shade the region above. So there's a difference on the region of where we should shade. So for this next example, x is more than or equals to 2. So when it's more than or equals to, we will shade on the right side. However, if we change it to x is smaller than or equals to 2, we will then shade the left side of the graph, of the straight line. So for this, we will, if we want to determine, when we see this kind of, if we can't imagine, then we'll have to do the working out. In this like complicated equation, we can straight away turn it back into the general form like we learned in the lower forms, which is y equals to mx plus c. So we'll change it back into this general form, and then we'll know y is bigger than or less than. So we'll know where to shade the region, whether it's above, below, right, or left. So for this example, I'll change it into the general form. So x is x minus y more than or equals to -4. So firstly I'll bring the x over so that the symbol remains unchanged. So it's negative x minus -4. Then I'll bring the -2 over. So for now, we'll have to change the symbol, and -x minus -4 over -2. So we can further simplify this into 1 over 2x plus 2. So y is smaller than or equals to 1 over 2x plus 2. So we'll shade the region below. However, if we switch y is bigger than this, we'll shade the region above. So it depends on where the direction of the graph points. Okay, so for this example, we can clearly see that y is more than or equals to -x plus 200. When we see negative, it means the gradient is negative, so we can see like the slope is going down. When it's positive, we'll see the slope is going up. So from here, we can see that the general form is actually y equals to -x plus 200. So if we change it back to the symbol this, so it's more than or equals to, so we shade the region above. So if we switch the sign, means we'll shade the region below. So it's like vice versa. So we can conclude that if the linear inequality sign is this, so we'll use dashed line, while if the linear inequality sign is this, we'll use solid line to draw the straight line of the graph. So from the graphs above, we can conclude that the region above the straight line satisfy the linear inequalities with this kind of sign, more than or equals to or just more than, while the region below of the straight line will satisfy if the linear inequality sign is less than, equal to, or less than, just less than. So if the line is like a straight line, horizontal line, or just a vertical line, then the where to shade will the satisfy the linear inequalities of more than or equal to or just more than. If we shade the left side, then it's less than or equals to or just less than. So for the next one, we'll learn how to write a mathematical model. The first question, the perimeter of the rectangular photo frame must not be more than 180 cm. So suppose that x and y are the width and the length of the rectangular photo frame. So So from here we can see there's perimeter means like the whole thing, the external or the whole thing. So from here we can see there's 2x and there's another y. So 2x plus 2y must not be more than 180, means it cannot be 180, it must be less than that, the total perimeter. Okay, understand? So for the next example, a hawker sells spinach and mustard leaves. The selling prices of 1 kg of spinach and 1 kg of mustard leaves are 350 and 450 respectively. The total sales of the hawker is at least 350 ringgit a day. So we'll represent X as the number of kilograms of spinach, while Y as the number of kilograms of mustard leaves. So for this mathematical model, we can write as 350 X plus, this is X, and 450 Y must be more than equals to 350, because it says at least, means it can be 350 but cannot be less than 350, but it should be more than 350, it means. Okay, so for the next example, we can see how to draw the linear inequalities graph. So from here, firstly, we want to turn it into a general form to ease our whole question solving operation. So the general form will be x minus 2y bigger equals to negative 4 and negative 2y, negative x minus 4, and y we switch the sign, negative x minus 4 over negative 2, and y must is less than 1 over 2 plus, oh no, wrong, so it's 1 over 2x plus 2, because it's like negative and negative. So if you want to know where to plot this kind of these points, we can use a simple method, which is the table method. So x and y. So when x is so when x is 0, when x is 0, y equals to 2. So when y equals to 0, when y equals to 0, so it's like when y equals to 0, 1 over 2x plus 2. So negative 2, 1 over 2x. So x will be negative 2 over 1 over 2 will be negative 4. So it's negative 4 over here. So when x is 0, y equals to 2. So when y equals to 0, x equals to negative 4. So we're drawing the two dots together, 2 points together with a solid straight line, as the linear inequality sign is more than or equals to. So this is how we draw a linear inequalities graph. But if we want to know where we want to where we should shade, we can refer to this equation, which is y is less than or equal to. So less than or equal to, we will shade the region below. So this is how we draw the linear inequalities graph. Simple as that. So for the last example, how to draw, we'll look at this example of 5y minus 5x is less than 25. So as usual, we'll turn it into the general form, y equals to mx plus c. So we'll bring the x over first. So we'll be left with 5y less than 5x plus 25. So if we bring the 5, this one over, we'll divide everything by 5. So we'll be left first with x plus 5. So when y is less than, we'll shade the region below. Okay. So in order to know where we want to plot our points, so we can put when x equals to 0, y equals to 5. When y equals to 0, x equals to negative 5. So when x equals to 0, y equals to 5. When y equals to 0, x equals to negative 5, and we'll connect it. But for this line, we need to be alert because of this sign, which means we use a dash line to connect the 2 points of the graph. Okay, so for the next example, we'll look. Mr. Andy plans to build 2 types of houses, A and B, on a plot of land measuring 10,000 meters square. After making a survey, he found out that 1 unit of house A requires 100 meters square of land and 1 unit of house B requires 75 meters square of land. So Mr. Andy has limited land. So the number of houses to be built is at least 200. So for the first question, you must identify the constraints in the problem. For the next one, we will write a mathematical model to represent the problem. And for the last one, we will draw a graph to represent the mathematical model obtained in question B. So for the first question, we can get to find the 2 constraints in the question. So for the first constraint, the land area owned by Mr. Andy is 10,000 meters square. And for the second constraint, it will be the number of houses to be built is at least 200. So from this constraint, we will form a mathematical model. So for the first constraint, 100x plus 75y, this is x actually, 100x plus 75y is less than or equals to 10,000. This is because he wants to maximize how many houses he can build in this limited 10,000 meter square area. Then, while house A is put in the equation unknown as x, and how the house of type B is as y. So this will be the linear inequality function from constraint 1. As for constraint 2, it will be x plus y must be more than 200. So the houses built must be at least, this is because it's at least 200. As for the last question, we'll draw a graph to represent the mathematical model obtained in B. So for the first constraint, 100x plus 75y is less than or equals to 10,000. So it's the same. We'll make it into the general form as y equals to mx plus c, and do the table as this. So y 0 when x equals to 0 and when y equals to 0. Then we'll get this line. We'll get to plot this line. So from here we can get like when x equals to 0, then we will get the value of the on the y-axis, and when y equals to 0, we'll get the value on the x-axis. So for second constraint, x plus y must be more than or equals to 200. So we'll make this into the general form, which is y is more than equals to negative x plus 200. Then we will use the table method again. Okay, the table method. x and y. When x equals to 0 and when y equals to 0. So when x equals to 0, y will be 200. Y will be 200. And when y equals to 0, x will be 200. So we'll get to plot this, and we'll use a solid straight line as the linear inequality sign is more than equals to. So we will shade on the region above. As for this, we'll shade the region below, because from here we can obviously see that it's less than or equals to. So for the next section, we'll learn about optimization in linear programming. So here's an example. Suppose a cake shop makes X chocolate cakes and Y cheesecakes costing 4 ringgit and 5 ringgit respectively. Then the total cost of making X chocolate cakes and Y cheesecakes is 4x plus 5y. And note that 4x plus 5y is a linear expression. If we want to determine the minimum value of 4x plus 5y, because costing, normally we want to spend the least in costing and earn the most in profit. So this linear expression is known as objective function. An objective function is written in this form: k equals to ax plus by. In order to determine the optimum value of the objective function, it can be obtained by moving the objective function line parallel to itself towards and into the region that satisfies all the constraints. So for this statement, we'll look further detail into the examples below. The optimum value is obtained by substituting the coordinates of the maximum point in the region into the objective function. So when we want to find the maximum value of something, we'll substitute the coordinate of the maximum value that we get from moving the line, the parallel line, the function parallel line to the maximum points of the graph. Okay. So for this example, the diagram on the right shows the shaded region that satisfy a few constraints of a situation. By using a suitable value of k, draw a line k equals to x plus 2y on the graph. And on the same graph, draw a straight line parallel to the line k equals to x plus 2y that passes through each point of the vertices of the region. So this is where we start to determine the optimum value, which is the maximum or the minimum. And for the next question, we will determine the maximum value of this function and the minimum value. So in order to draw the straight line, the parallel line, we have to find the value of k. In order to determine the value of k, there are 3 steps. So first step, we have to note that from this equation, this general equation, okay, note that A and B are coefficients of the x and y respectively. So second, we have to find the common multiples of A and B. And last step, take k as the common multiple. So we'll take the common multiple of the both values A and B, and k will be that value. So in this question, we can take 4 as the common multiple of the invisible A and the B as 2 over here. So we can substitute the value of k. So we'll get x plus 2y equals to k. We'll get this. So we can plot the graph. We can draw the straight line. So in order to draw the straight line, we can also use x equals to 0 when x equals to 0 and when y equals to 0. So from here, when x equals to 0, y equals to 2. When y equals to 0, x equals to 4. So from here, I'll zoom in the graph and show you how we can plot. How we can plot on the graph. Okay, so this is 1 and this is 2. So it will be over here 2 and 1, 1, 2, 3, and here's 4. So the straight line will be connecting these two dots. And so we will move the line that we draw just now parallel to every point, every intersection point of the graph that we drew. Okay, so from here we can see that the maximum is this and the minimum is this. So these two coordinates will be used for the following question, which is B. So for B, we can substitute the maximum point from the shaded region, which is the point that we took is 15, 55 into k equals to x plus 2y. So for the k just now, that k we use for is because we want to draw this line only. So when we want to find the maximum point, we take back the original one. So when we substitute k, so this is x and this is coordinate y. And x is 15 plus 2 and y is 55. So from here, we do step by step. And 2 times 55, we get 110. And 110 plus 15, we get 125. So therefore, we can see that the maximum, we can make the conclusion by putting like these three dots over here. The maximum value. So I write short form here, but you have to write full in exam. So the maximum value of k is 125. So this is the answer. So the next we want to find the minimum value. So from the minimum value we can take this equation, this coordinate. So it's 15, 8, 15, 8, and 15 is the x coordinate and y and 8 is the y coordinate. So we'll substitute the minimum point from the shaded region into this equation, same as the maximum point that we used. So k equals to 15 plus 2 and the y coordinate is 8. So 15, 8 times 2 is 16. 15 plus 16 will get 31. Yes, 31. So therefore, the conclusion, the minimum value of k is 31. It's 31. Okay. Yes, we have finished subchapter 7.1. So actually you can try to do formative exercise 7.1, question 1 and question 3. It will be the same way like how we solve all these examples. Just extract the information step by step, then we'll be able to get the answer easily. So moving on to the next subchapter 7.2, which is about linear programming applications. So here we will apply what we learned from the previous. So solving problems involving linear programming graphically, just like just now, where we need to plot the graph, and from there we will use the values of the graph to coordinates to find our answer. So first thing first, we have to identify the existing constraints. So for this step 1 and step 2 and step 3 is just like what we learned in the linear programming model just now in the previous subtopic. So second, we have to determine the objective function. Third, define the values for all the decision variables that satisfy every constraint. And for the fourth, a value that satisfies the constraint is known as feasible value, while the value that does not satisfy the constraint is an infeasible value. So if the problem has a solution, then all the constraints will result in one common region that is defined as the feasible region, which is the shaded region that consists of all the feasible values. Okay. A solution in this region is known as the feasible solution. So from the glossary in our textbook, it says that feasible region or rantau tersaur is a region that satisfies all the mathematical model requirements for a situation. So from here, it might look and it might sound confusing, but don't worry, we will cover it in the following examples. So for this application, I'll be taking one example to explain it. A trader wants to arrange X bouquet of roses and Y bouquet of orchids. The time taken to arrange a bouquet of roses is 20 minutes, while a bouquet of orchids takes 30 minutes. The process of arranging the bouquet of flowers must be based on the following constraints. So for the first constraint, they have given you, and the second constraint. So from these two constraints, we have to make a mathematical model. If not, we won't be able to further and further to solve the question. So first constraint, the number of bouquet of orchids must not be more than twice the number must not be more than is the key word of this constraint, and twice the number of bouquet of roses. And for the second one, the number of bouquet of orchids must be at least, so this is the keyword for the second constraint, 14, at least 14 actually is 1 over 4, typo over here, 1 over 4 is actually 1 over 4 of the number of bouquet of roses. So for the first question, write a mathematical model involving a system linear inequalities to represent the constraint 1 and constraint 2. And for the second one, the third constraint which is represented by the pink region in the diagram. So this is the diagram. It's the time taken to arrange the bouquet of flowers. So write the constraint in words. They want it in words. As for the last one, construct and label the region R that satisfy the three constraints above. Region R is where all the shaded region in the set using the same graph. And find the minimum number of bouquet of orchids if the number of bouquet of roses is 30, and the maximum profit of the trader if the profits for each bouquet of roses and each bouquet of orchids are 35 ringgit and 25 ringgit respectively. So from the first for so we'll form a mathematical model as requested by the question for constraint 1 and constraint 2. So constraint 1, the number of bouquet of orchids must not be more than twice. Must not be more than twice. So y will be, this is y, okay. Y must not be must be less than or equals to 2x. So this is the number. So this is the answer for the mathematical model answer for question A. So it's y less than or equals to 2x. So for constraint 2, the number of bouquets of orchids must be at least 1 over 4 of the number of bouquets of roses. So from that statement, from the constraint just now, we can form these, oh, error, this mathematical model. So this is from constraint 1, this is from constraint 1, and this is from constraint 2. So moving on to the next question, we'll look into the third constraint, which is represented by the pink region, and we have to write the constraint in words. So from here, we can, okay, so hang on. I'll screenshot this graph and bring it to lower down. Okay, so it'll be easier. Oh, it's not working. It's okay, I'll just do it on this slide. So for here, we can extract the points, the coordinates of 0, 60, and 40, 0. So from here, we can find the gradient, which is y2 minus y1, the formula m equals to y2 minus y1 over x2 minus x1. So the gradient will be in Sm 60 minus 0 over 0 minus 40. So from here we will get negative 3 over 2. And we'll have to form the equation which is in the form of y equals to mx plus c. So for the equation of the straight line, we can see from here the y-intercept is 60. The y-intercept is, so c equals to 60. So from here we can write it into negative 3 over 2. M means y equals to mx plus c. Mx plus 60. So if we want to just make it, if we don't want fraction in the equation of straight line, we can times 2 for the whole equation. Times 2, we will get 2y 2y plus 3x plus 220. For to ease, I just brought this one over here. So they want it the constraint in the form of in words. So from here we can conclude that the total time the total time to arrange the bouquet of flowers is at least 2 hours, because it's from here 120 divided by 60, we get 2 hours. Okay, so this is the answer as they want it in words. So for C, they want us to draw it on a graph. So we uh, just take x when x is 0, when the value when x equals to 0, when y equals to 0, just for this line and this line is the same actually. So when y equals to 0, so when y equals to 0, x will be, when y equals to 0, x will be 4. And for this one, when x equals to 0, y when x equals to 0, y will be equals to 0. So we'll substitute to just like the table method that we learned just now. X and y. This one, we just draw it this. Due to time constraints, I'll go to the next question. So we will have to find the minimum and the maximum profit. So for this, we will substitute x equals to 30 into y equals to 1 over 4x. So when y equals to 1 over 4, 30, y will be 7.5. So there's no 7.5 bouquet of flowers. So we round up, we will get 8 bouquets of orchids. The minimum number of bouquets of orchids is 8. This is because from the graph just now, because they said the minimum number of bouquets of, if the minimum number of bouquet of orchids, if the number of bouquets of roses is 30, so so from the graph we can see that is this one. So we can get 8, the value 8. So for the last question, they want the maximum profit. So from the shaded region, we can see that the maximum point is over here. And we will take the coordinate 18, 33 and substitute into, just like we used just now, the 35x plus 25y. You must be wondering where I got this. Is actually from the question given. X will be the orchids and y will be the roses. Okay, it's over here, 35 and 25 respectively. So I'll substitute 18 and 33. 35, 18 plus 25, 33. This is 25. So I'll get k equals to 1,455. So the maximum profit made by the trader is this value. So the max profit equals to RM 1,455. So that's all for this chapter, and that's all from me. So thank you for watching. So actually, y'all can try doing the formative exercise 7.2, like question 1 and question 2, to test if you understand the chapter. So most importantly of this chapter, we must know how to sketch the graph and make the form the mathematical model. If not, we won't be able to solve the question in this linear programming chapter. So here just now we sketch, this is the k, so we will like this one and this one. So this is the max, and okay, that's all from me. Okay, thank you.